Hello everyone, it's Mr. Rops,
And Mr. Walker?
and we're here today to talk about modeling functions. And this is one of the biggest ideas that we can actually teach in mathematics, is everything in the world pretty much is some kind of a function of some sort. So let's get an example of what we're talking about. Here we have a wonderful graph of PayPal, Facebook, and Twitter. And these are the number of the years since 98 and so on. And now each of these units are in billions, but PayPal is about billions of dollars. Facebook, what's Facebook say?
Billions of photos uploaded.
Okay, and then Twitter is the number of tweets. So even though the numbers are the same, the units of this vertical axis are different. All right, and so we have different graphs here to look at it. And if you look at your questions, we want to consider the three sets of data, determine if a linear model, linear implies a line, if it would fit a line, is reasonable or not, and explain why for each. Well, let's go back here. And if it's going to fit a line, then we're going to need a line. Okay, so here's my line. Does it look like, Mr. Walker, that first one would fit a line reasonably well for the PayPal, the green one?
Well, not every point is on the line, but yeah, I think there's a nice average linear look to that.
Right, so I would say that the first one is, so for PayPal, I would say yes, a linear model is reasonable. If we go to the next one, let's see if we look at I'll keep this one here actually. Let's get a different color. Let's go away. Get a different color. Let's go to blue, let's say. Ooh, and we go, put something here. And again, if I move this line around a little bit, kind of see what's going on, would you think that would be not exactly, but a reasonable to say that it's going to be a linear model, that we could use it to predict things?
Yeah, I think if you ignore those first 2 years, or if you just kind of assume that that's just beginning, then yeah, I think that looks, again, not parallel, but yeah, linear.
Right. I would think it would be reasonable for a model for linear as well. And now this is not an exact science, and so many times in mathematics we want the exact answer, or that's what it seems like, but there's opinion in this case. And let's look at the very last one, and let's make this one black. And we'll make a line here, kind of. So now if I look at that, does it fit the tweets at all? There's a whole bunch down here and down. In this case, I don't think a line would be a reasonable representation. And so I would say that for Twitter, it's not reasonable because it does not fit a line. And that's basically what we can say. We can look at it and go, there's a definite curve pattern to the Twitter ones. There's a touch of a curved one to the Facebook ones, but not nearly as much as it is right here.
Mm-hmm.
And same with even the PayPal one, a touch of a curve, but it's pretty linear overall. I think in the real world, finding absolutely perfectly linear data, does that happen?
That does not happen very often. No, that doesn't. It's rare indeed.
Right.
And you're only dealing with a few points here too, so it's hard to look at long-term lines.
Exactly. All right. So the first two are reasonable linear. The last one is not. For the PayPal and Facebook, estimate the slope and explain the meaning in context. Well, if we want to estimate the slope, let me clear some of this writing here. We know from earlier that slope is equal to, well, in math we always talk about the change in y over the change in x.
And we do in science too.
All right, and this is the dependent and independent variable. And so here we don't have x's and y's, but x is the horizontal and y is the vertical. So if we want to estimate the slope of PayPal, well, let's look and see what the points we have. I know this pink line is close to the line that would be a best fit line. So this might be a point here, and I can estimate that. What's that x value going to be? I don't know. Since we're estimating it, I might even say 2010. 2010.2. Let's keep it 2010.
2010.
And then 100 billion. And if I estimate maybe down here, or even here, let's say, that's an estimate as well, then that's going to be, well, my year is going to be 2000, and my maybe 10 billion.
Yeah, that looks, 10 billion.
Okay. And so then I have to do my slope. It's going to be the y values, the vertical values, which is 100 minus 10 over 210 minus 2000. Did I do my math right there, Mr. Walker?
I think so, yeah.
Okay, so then I get 90 over 10, which is 9.
Mm-hmm.
Okay, now it says, this question says, explain what this thing means in context. Well, if I'm going to think about what this means in context, let's think about what this top variable in this case, what's the top variable in this case?
Well, for PayPal, that is billions of dollars.
So dollars in the billions. And the bottom is the x values, or the horizontal axis, and that is years.
Years.
Okay, and so if we're going to interpret this in context, we're going to use the idea of the independent variable first. And I'm going to say, as the year, that's the independent, as the year increases, so that's the independent variable, and I'll underline that with blue, increases. Well, there's a hiding 1 underneath there. By 1, the, what are we looking at? The y value.
Billions, yeah, the billions of dollars.
The billions of dollars increase, and we should add this word on average. That's an important word, average, by 9. So as the year increases by 1, the money increases by 9 billion on average.
Mm-hmm.
So each year it's getting more and more by $9 billion. That's quite a substantial increase. I think I'd like to have PayPal. All right, so that's how we can do these contexts. Let's copy this one and do the same thing for, let's clone it, and we will delete the ink. Okay, so let's now go and do the same thing for the Facebook. All right, so Facebook, again, we want the slope. We need to get some points. Now, if I look at the orange one, let's pick this value here, which looks to be 212, or
2012.
2012, and a billion. And down here, it hits here at, let's say, 0. Oh no,
Well, we've got a number there, right?
Ooh, we do. We have so 2006, and what's that? That's going to be 0.5 billion?
Yeah, 0.5 billion.
0.5 billion. Okay, so again, we are going to do the change in y values, 100 minus 0.5, over the change in the independent variable, which is this, subtract. Subtracting that, I get 99.5. And this is 6. And if we quickly do 99.5 divide 6, we get 16.6. Approximately 16.6.
Now, what does that mean?
That's a very good question. Now, again, I'm going to start with independent variables. And the independent variable is year. So as the years increase by 1, the Facebook is talking about photos.
Yeah, photos uploaded.
There are, on average, 16.6 billion photos uploaded. So as years increase by 1, there are an average of 16.6 billion uploaded. So it's increasing by a lot each year.
Yeah.
There's a lot of photos going on into Facebook.
To segue into the next question, I would say a bigger increase than the PayPal.
Oh, indeed, because the PayPal was 9, exactly. And so if we look at the next question, where did it go? It's how do the two slopes compare, and what does it mean? Well, as Mr. Walker just said, this is 16 for Facebook versus 9. And I can even see by the slopes of the angles of these lines that the blue one is steeper than the pink one. And so what does it mean? What it means, how do they compare? Well, the PayPal is less than the Facebook. And so the Facebook is steeper and growing at a faster rate. It's the rate than PayPal.
But they're both positive.
They're both positive. They are both growing.
They're both growing.
Yep. That's if you are making money in PayPal, that's a good thing. If you're uploading, if you like photos going on Facebook, then that's a good thing as well. All right, and finally, last question. For the PayPal, interpret the meaning of the point that cuts the year axis.
That's the horizontal axis in this case.
Indeed. So what that's talking about, the horizontal axis, let's get rid of these calculations here. And it's talking about what does this value here mean where it cuts the axis? Well, when it cuts the y-axis, I know that the height here, which is money in billions processed, so the money is 0 billions. And so if I estimate this, it says in 1998 there were $0 billion processed. That's what the interpretation of the y-axis does. So when the vertical axis is 0, what's the year axis telling us? Okay, so there's your introduction to modeling functions. Real-world problems are never really nice. You have to do some intelligent thinking here to do some reasonable estimating and then do some mathematics and interpretation of your results. Good luck.